Okay, so first let's look at the questions on 389 that'll finish up mirrors, 9, 10, and 11. So number 9 says, a dentist uses a small mirror of radius, so our R is 40 millimeters, of radius 40 millimeters to locate a cavity in a patient's tooth. If the mirror is concave and is held 16 millimeters from the tooth, so the DO is 16 millimeters. And from our R, we can get our F is 20 millimeters. So right away, when I write this down, I'm like, oh, so the object is between F and the mirror. And if the object's between F and the mirror, it means the image is going to be virtual. And so when I figure out my DI here, I should end up with a negative number. It wants to know what is the magnification of the resulting image. Okay, so we're looking for M, but before we can find M, we have to find our DI. So we do 1 over F is equal to 1 over DO plus 1 over DI. So 1 over DI is equal to 1 over F minus 1 over DO is equal to 1 over 20 millimeters minus 1 over 16 millimeters. Common denominator would be 80. So 1 over DI will equal, this is 4 over 80 millimeters, minus 5 over 80 millimeters, which is negative 1 over 80. So DI is equal to negative 80 millimeters, where the negative means virtual. Okay? And so then to do the magnification, remember, hi-ho, di-do, it's off to work we go. And this time we need DI over DO. And there's a negative on the DI because of the virtual. So M will be equal to a negative 80 over DO was 16. And so the magnification is 5 times. Okay, it's 5 times and it's bigger. So that's number 9. Number 10. A production line inspector wants a mirror that produces an upright image with a magnification of 7.5. Upright means it's going to be virtual. Magnification 7.5 times as big. When it is located 14 millimeters from a machine part. So if it's when it means the mirror, so the DO is 14 millimeters. Okay, and it wants to know what kind of mirror would do this job and what is the radius of curvature. If you wanted upright, it means you wanted virtual, and if you wanted virtual and it's bigger, the only mirror that gives you virtual and bigger is, back to our cases for mirrors, there's 2 virtual cases. One is when the object's between F and the mirror when it's a concave mirror, and the other is when it's a convex mirror. They both result in virtual images, but the one that results in bigger is the concave. A convex mirror always makes an image that's tinier. So the answer here is it needs to be a concave, converging mirror for part A. And what is the radius of curvature? So we need F. So first we need DI. So we know M is equal to negative DI over DO. So DI is equal to negative M times DO. So DI is equal to negative 7.5 times 14 millimeters. DI is equal to, that's like 15 times 7, so 460, 105, I think, maybe? Doing it in my head, and it's negative because it's virtual. Alright, so then we go and find F. So 1 over F is equal to 1 over DO plus 1 over DI. So 1 over 14 millimeters plus 1 over negative 105 millimeters. Common denominator will be 210. So 14 goes into 210 15 times, I think. So 15 over 210 minus 2 over 210, which gives us 13 over 210. So F is equal to 210 millimeters divided by 13. In other words, F is equal to 16.154 millimeters. But that's not what the question asked. The question asked what must be the radius of curvature. It's equal to 2F. So R is equal to 32.308 or something thereabouts millimeters. All right, that's number 10. Number 11 says, shiny lawn spheres placed on pedestals are convex mirrors. One such sphere has a diameter of 40 centimeters. So if it has a diameter of 40, and I said centimeters, is it really? Yeah, 40 centimeters. It means it has a radius of 20 centimeters, which means its F is 10 centimeters, and it's convex, so it must be negative 10. A 12 centimeter high robin, that's HO, sits in a tree 1.5 meters from the sphere, DO, 1.5 meters. And it wants to know where is the image, DI, and how long is the robin's image, HI. Okay, so first we do 1 over F is equal to 1 over DO plus 1 over DI. Whoops, that's really an I, it just looks like an O. 1 over DI is equal then to 1 over F minus 1 over DO. So it's equal to 1 over negative 10 plus 1 over, and 1.5 meters is 150 centimeters. And I'm going to switch to centimeters just to make our lives easier rather than to meters. Common denominator is 150, so this will be negative 15 over 150 plus 1 over 150. Whoops, except it's a minus, isn't it, when I took that over? So negative 16 over 150. So DI is equal to negative 150 over 16. So negative 9.375 centimeters, where the negative means virtual. I also wanted HI. So HI over HO is equal to negative DI over DO. So HI equals negative HO DI over DO. So HI equals negative. Told us the robin was 12 centimeters high. We just found this to be negative 9.375. And the DO was 150 centimeters. So the HI is going to work out to be a positive because of the two negatives. And it works out to be 0.75 centimeters. Tinier because it's a convex mirror. All right, so then we're going to go back to page 381. And on 381, there are 4 questions there. So number 13 says, use a ray diagram to find the image position of an object 30 centimeters to the left of a convex lens with a 10 centimeter focal length. Okay, so this is number 13, and I'm going to run out of time. So here's F, here's 2F, and the object's back here, because it said F was 10 centimeters. On this side there will be an F, and there will be a 2F, and it wants you to find